Welcome back to the channel. Today we will be doing system of equations. Today's lesson will be a little simpler. So we normally start easier, then it gets a little bit harder. So we will be doing a little bit of examples, a worksheet, and then the part 2 to this will be just dedicated to answering the regents questions, which is one of the biggest points on the regents. That's 6 whole points. So for part 1 today, we will be doing a little bit of worksheet, 2 worksheets, examples, and then part 2 will be dedicated solely for the regents questions. So let's jump into the video. So as per usual, test your understanding. You're gonna pause the video for at least 3 or so minutes, maybe 2 to 3 minutes. We're gonna read together. You're gonna pause the video. If you need to do a reread, if you need to do 3 reads, that is completely fine. But pause the video and answer the question, what could the 80 represent in this situation? So let me read the scenario. So it says cement is made by mixing water and concrete mix. The amount of water, W, added to the concrete mix can affect the strength of the material. 1 liter of water weighs 2.2 pounds. The equation 2.2 W plus 80 equal 86.05 represents the relationship between these quantities. What could the 80 in this situation represent? So take 2 to 3 minutes, reread it, highlight if you need to highlight key points, answer what you think the 80 is, and then at the end of this video I will go over annotating and answering what the 80 would represent. Okay, so now we're going to move on to this part. First activity, activity 1. Write an equation to represent each situation. Okay. A. Blueberries are $4.99 a pound. Diego buys B pounds of blueberries and pays $14.97. So I always tell my kids, my students, let's zoom this in a bit. I always tell my students, turn on this slide. Okay. Highlight the key points. So we know blueberry costs $4.99 a pound. He buys B pounds, so we don't know how much pounds of blueberry he bought, and he paid $14.97. So the equation, literally picking the information that you highlighted and rewriting it into an equation form. So $4.99. We know he buys B pounds, and he says pays, so that would mean that that's your total. So this would be your total. And then the B varies, so the weight would vary. So we don't know how many pounds he bought. And that's why you would use a letter to represent the different pounds. And then the total is $14.97. And this would be times. So I always tell my kids, look at this situation as you working. Say you work $8 an hour. You work 14 hours. So this is per hour. I'll do it shorthand. Per hour. And this is the amount of hours worked, right? To get how much your total pay would be, you would have to then multiply the $8 an hour times the 14 to get how much your total would be. And that is how I would tell them to look at this question. The $4.99 is for 1 pound. We don't know how many pounds, so it would be this times, say he bought 2 pounds. This times 2 pounds will give you this. And then their total will be $120. So that's how I kind of bring it to life for them to see it. They work $8 an hour. They work 14 hours. They will get this as their pay. Okay. For B, it says blueberries are $4.99 a pound. Jada buys P pounds of blueberries and pays C dollars. Same idea. Same exact idea. Highlight your key points. So we know this is how much 1 pound is in dollars. She bought B pounds. We don't know how many pounds. And she paid C dollars. So you would say let me put dollars in, $4.99 P equal C dollars. And then we know that we are multiplying how much 1 pound is times the amount of pounds that she bought. And then for C, same idea again. Blueberries are D dollars a pound. Lynn buys Q pounds and pays T dollars. So we would say D times Q equal T dollars. And your answers should look something like this. So you're literally reading each scenario, highlighting. So if you don't have a highlighter, you underline. Highlighting what the key points that they gave us. And then you grab those high points and put them in an equation form. Okay. We are not going to do this part, but we are going to do a worksheet. So let me grab that worksheet. So that was the first part, just you having warm up, feeling how it feels to create a single equation. Now what we're going to move on to is creating 2 equations and being able to solve each of those equations. And that's why the regents is 6 whole points. So the first one is already done. I'm going to skip that and have us focus on number 2. So we're going to do number 2 and number 3. And number 5. So it says Judy worked 8 hours and Ben worked 10 hours. Their combined pay was $80. Judy worked 8 hours and Ben worked 10 hours. Their combined pay was $80. When Judy worked 9 hours and Ben worked 5 hours, their combined pay was $65. Find the hourly rate of pay for each person. So already highlighted, because when I copied this, I did already highlight the key points. So the points that are in green, those are the highlighted key points. So with that being said, we're going to grab these worded sentences and put them in our equation. Now we need to have 2 equations when we're trying to solve. We're tasked to find the hourly rate for each person. So we have to figure out how much Ben worked and how much Judy worked an hour. Similar to this question that we did on this side where I used this example. So that's what we need to find out. Okay. So it says Judy worked 8 hours. So we say 8. And we use J to represent Judy. So she worked 8 hours and J is for Judy. Whenever you see the word and, that means it's a plus. So 8J plus, should color code each person. And Ben worked 10 hours. So we're going to say 10 B. 10 is the amount of hours he worked and B is representing his name. Equal, their combined total was $80. So between both of them, they made $80. Okay. We're then going to move on to sentence 2. When Judy worked 9 hours, so we say 9J, and we know the word and means plus, plus. Ben worked 5 hours, so we say 5B, equal $65 in total. If you need a minute, definitely pause the video, rewind, and if you need to look at this again, what I just did, how I grabbed those information, definitely do that. Don't move on until you understand what each of these colors mean. Okay, so if this is a 6-part question, which the Regents is 6 scores, you already will get a 2 point, and it all depends on how the question is divided, but you would already get 2 points here for just setting up your equation. Now the other part is where it gets complicated. I'll try my very best to explain it as simple as I can. So we know that our goal is to figure out how much money they made an hour for each person, for Ben and Judy. And we got to get that information from this. So what we're going to do, we know our variables, the J and the B. We want the coefficients to be the same for one of the variables. And remember, a coefficient is a number that is in front of your variable, your letter. So I know this is the biggest number for J, so I need to probably get the 8 to be also 9. What can I multiply by 8 to get 9? There's not a possibility. B. Look at your smallest, look at your largest, and you're going to say, is there a number I can multiply by 5 to give me 10? Yes. 2. So the one that you can multiply, the smallest number, you're going to put a parenthesis around it, put the 2 outside, and the last thing you're going to do is, remember from the previous video, in the steps given, we stated that we always want to get or opposite coefficient. So you will multiply one or both equations by non-zero constants so that one variable has opposite coefficient. So if it's 3x, you need it to be negative 3x. So in this case, if we're going to get this to be 10, we need one to be positive 10 and one to be negative 10. And because we're able to modify or edit the second equation, we're going to put the negative on the 2. So we're going to get positive 10 and negative 10. Reason being, you want to subtract both. You want to be able to cancel out one. So when you say 10 minus 10, you get 0, meaning that you cancel it, and that is what you want. So you want to cancel B to be able to solve for J. Also, if it's a situation where both numbers like this, you have 8, you can't multiply anything by 8 to get 9. If it was the same thing for B, then what you would have to do is that you would have to find a number that you can multiply both equations to get the same number. So you would have to figure out a number that you can multiply to get the same coefficient. But in this case, these examples are pretty simple, so you're not in that position where you have to figure it out. Okay. So now that we're here, the equation that we are not going to modify, we're not doing anything to, we're going to simply rewrite it. So we're going to say 8j plus 10b is equal to 8. If you feel comfortable doing all the math on the side, do that. So we need to do negative 2x times 9j, that gives you negative 18j, negative 2 times 5b, that gives you negative 10b, and negative 2 times 65, that gives you negative quote me, let me double check. So, negative 2 times 65, is correct? Yep, negative 130. So I am correct. So if you feel comfortable doing that rough draft on the side, you can. If you feel like you can multiply it across and just write it in, then do what you do. But make sure everything is matching under each other. They're connected. It should not be plus, it should be a negative. 10b equals negative 130. Okay. So all of this, you write it underneath, connecting the b's, the j's, and the constants together. Now, the simplest part we're at. All we gotta do is, once we set up everything correctly, we're gonna just put it in the calculator. So it will be 8 minus 18. Again, if you're not good with signs and figuring out, then let the calculator be your best friend. There's no shame in the game. Then the other one says 10 minus 10 is, that is what we wanted. That's why we wanted one to be positive, one to be negative, and both to have the same coefficient. This cancels. Then we're going to say 80 minus 130. That is equal to negative 50. Again, what I've always been reiterating. Never want to leave a variable in a negative state or with a number greater than 1. So this is a negative 10. So we're going to divide by negative 10 on both sides. Always what you do on one side, you have to do it on the other side fully. These will cancel and we're left with j is equal to positive 5 because the negatives will cancel, and again, if you have issues with your signs, use your calculator. Negative 15 divided by negative 10 gives you positive 5. Do not be ashamed to use your calculator. Okay. Now, we know how much Julie worked an hour. We now have to figure out how much Ben worked an hour. So we're going to go back to our original, the colored equations here. We're going to go back to them, choose whichever one we want to use, and I will choose the second equation, 9b. You can choose the first one. It does not matter. It should still give you the same answer again. So I chose the second one, rewrote it. Now, I'm going to look for the answer that I found before and I realized it's j. I'm going to look in this equation and I realize j is here. So I write 9, j represents 5, so I replace it with 5. Do not write j5, but I just write 5 instead of the letter j, because the value of j is 5. Plus 5b equals 65. Then I'm going to do some simple math. If I don't remember my times table, I'm going to say 9 times 5 is 45. So this is 45 plus 5b equals 65. Now I'm at another fun part. I'm going to cover this 5b and I'm going to ask myself, is there any other variable, any other b in this row other than the one that I'm covering? If my answer is no, then I'm going to move on to the next thing in line. I have this 45 and I have a 65 left. I cover the 45, which is a constant, and I'm going to say, is there another constant in this row other than the 45 I'm covering? My answer is yes. So it will be the 45 and the 65. Those are the only two that I can combine because they are like terms. They are numbers without a letter attached to it. Because this is a 45 and I need to move it to the other side, I'm going to do negative 45 minus 45 is 0. I'm left with 5b is equal to 65 minus 45 is 20. Do not have enough space, I'm going to rewrite this here so I can simplify. Never want to leave variable in a negative state or a number greater than 1. So I'm going to divide by the 5 that is attached to the b. And my answer is b is equal to 4. 20 divided by 5 is 4. So Ben only worked $4 an hour and Judy worked $5 an hour. This is a great example. This is a very practical example showing how students always say that we don't use math. I don't see how I use math in real life. You're always using math, you just don't know that you are. And this is a practical way of seeing it. Right. We're going to jump down to question 5. I feel like the Regents questions are more of practical sense. 1 and 2, I don't want this video to be too long. So while we can do number 3 and number 4, if you do attempt number 3 or number 4, comment down below and let me know what you got for your answers and if you would like for me to do that in another video. But for the time that we have now, do not want this video to be too long, so I will just move on to question 5. Question 5 says, the talent show committee sold a total of 530 tickets in advance. Student tickets cost $3 each and the adult tickets cost $4 each. If the total receipts were $1,740, how many of each type of ticket were sold? Okay. Again, it might seem overwhelming, but take your time. So, first information given is that there is a total of 530 tickets sold. So this is total 1 because I remember reading and I saw another total somewhere else. So this has to be total 1. You can't combine two totals. You have to separate them. The next total is here. So this is total number 2. Okay. They said that student tickets cost $3 each and adult tickets cost $4 each. Good. As long as you can identify your key information, you are good to set up your equation. Okay. Right. We're missing one information somewhat, but it's given to us indirectly. So I would always suggest start with your totals first when you're writing. So we're given 530 and we're given 1740. So $1,740. Okay, so we got this set up. If you need to cross it out, do that to show that you already used it. Then what's next in line is that we underline that student tickets cost $3, adults $4. If we look on our total, we realize the only one that has the same unit with a dollar amount is the second one. So if this is in units of dollar, we have to connect the left side, which is the one that we're going to work to find the total. It also has to be dollar amount. So it's going to be 3s plus, and again, when you see the word and in a sentence in math means addition. 3s plus 4a equals 1740. And if you don't understand how I got the s and the a, the s represents students, the a represents adults. Perfect. Then this is where I'm saying we were given the information, but we weren't given the information. We have to then interpret it. So if we know 530 tickets were sold, we're going to ask ourselves, who did they sell these tickets to? And if we know that each student and adult tickets were this, then we know that they sold tickets to students and adults. that is it for this question. Well, for now, that is how you would come up with your equations. So now we have to do the same thing we did here. Eliminate one variable, solve for the other variable, then plug in that solved variable in one of the equations. Okay, so let's go step by step again. Same idea as we did before. You're always looking at your smallest number. So these are our smallest numbers. This is 1. And again, when you don't see a number attached to a letter, typically it's an invisible one. So our smallest number here is 1 and the biggest is 4. Smallest is 1, the biggest is 3. In this case, it's very easy to choose whichever number you want to use because both variables in the first equations are 1. And you know you multiply 1 by any number, you get that same number again. Okay, so I will choose 3. The equation that it has the smallest coefficient, smallest number, that's the one I'm going to put my parentheses around. Because that's the one I'm going to multiply to get to be 3. So I'm going to put the 3 outside. And because both are positives, and the s's are positives, I'm going to put a negative on the 3. Okay. So again, if you need to work it on the side, do that. And then negative 3 times 1a is equal to negative 3a, and negative 3 times 530 is equal to, you either can do long math or to save time, you can simply put it in your calculator and it will give you the answer. Negative 1590. 1590. Okay. If you want to do this rough draft math, it is perfectly fine. I am showing you different ways you can do the math. Or if you are just boom, 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 write it out, do that as well. Do what floats your boat. We're going to take the answers here, rewrite them here. The first equation is the one that we edited, we modified. So we have negative 3s minus 3a equal negative 1590. Then the equation that we did absolutely nothing to, simply rewrite the correct letters under each other. Like this. So you always want your S to be under S and your A to be under A. Okay. So we say negative 3 plus 3 is 0. So we know this cancels. Then we have negative 3 plus 4 is 1a. And negative 1590 plus 1740 is equal to 15. So now that we figured out the value of A, we have to figure out the value of S. So how many tickets did they sell to students? Again, as per usual, we're gonna grab one of our original equations. The easiest one I see to use is the first one. So it's S plus A equals 5. All right, so we know the value, how much they sold to adults. We now have to figure out how much tickets do they sell to students. And this should be the simplest part of it. So we're trying to figure out how many students, so we put the S plus A represents the 150 because we know the value of how many tickets were sold to adults. We're then gonna cover S. Ask the question, do I have any other S in this row? My answer is no. then I'm going to cover the 150. Do I have any other constant in this row? And I can answer and say yes, the 530. So if these are both constants, I'm going to combine both of them. I'm going to move this 150 from the left to the right. S is equal to 380. Now if you want to do a tester, you use the same equation. S plus A is equal to 530. So you want to test if both these numbers are correct. S is 380 and A is 150. When we add both of those, we should get 530. So 380 plus 150 is indeed 530. So it's 530 equal 530. Right. And that is that portion. So now we will move